Hey, just thought I'd make a little video about my chiller. Just got it up and running this morning. I had to do some repairs to a small leak up on the top of the evaporator barrel here. It's just running on one circuit at the moment, circuit 2, which is these two compressors, and currently it's just cooling. Well, it was cooling that heater, but it's just cooling the room at the moment. So yeah, I'll run you through it. This controller is, I set up the duty cycling, so basically every time it starts it'll either select this or this, depending on what started last. It'll do the opposite, just to keep the amount of run hours, or I guess the wear on the compressors, even. And so I've got a set point of 7 degrees Celsius for my water. So once this guy here reaches 7 degrees, which it's currently at 9, the whole system will turn off, and at 11 degrees we'll have the second set of compressors kick in, and then they stage on one at a time. So when I first turn the system on, compressor 1, well in this case compressor 3, is set to run first, and then I've got a 1 minute delay, and then compressor 2 will turn on, and then yeah, if we exceed 11 degrees, compressor 3 will turn on, and then a minute delay, compressor 4 will turn on. And then the reason for the delay is basically like a load duty type thing. So if the load is satisfied with one compressor, then the second one won't kick in, within a minute. That's usually not the case, so would always run 2. But if that third one kicks on, then it might be satisfied. I might change this timer to 10 minutes or something, just to play around with it. With four of them running, the suction temperature comes down really fast, and it sometimes trips out. It tripped out just before, but yeah, I've added a little bit more gas and it's no longer tripping, which is cool. But the main part of this project was for it to look and run like a industrial or a commercial chiller, like just a V coil air cooled chiller, and I got the fan deck on top, and I was lucky enough to find a whole bunch of matching coils and fan decks. They're from like Underbench hot water and chilled water, water cooler and heater, for in an office kitchen type thing. And we had a guy drop off a whole bunch for destruction, and I managed to get some parts off them, which is pretty awesome because it meant I could make these little V-shaped condensers, and they're all micro channel. So yeah, so we've got the compressors, and they come through here, and they all have a this is the suction line, which is connected between all 4, and then come down here and you notice that the discharge is only connected to 2, so we've got 2 high side circuits, which is what I was showing you on the front here. So this is the compressors getting signal, so there's 2 high sides, and then we'll come to this in a second, but 1 low side. So that's the suction line, which gets shared between all 4 compressors. So from the compressor we have the tiny little 1/4 inch discharge, which comes into this oil separator. I managed to get 2 oil separators that were identical, which was also a big positive for this project. I wanted everything to look like it was kind of designed for this, so I really wanted all the compressors to be the same. I wanted the heat exchangers to all be the same, and yeah, so I got these 2 oil separators. They're both from ultra low temp freezers, -80 freezers. So the reason that we want an oil separator is because of this. So this is a flooded shell and tube heat exchanger, and we'll get to that later actually, because we haven't quite gone around. So the discharge drops its oil, goes through the V stack, and because so there's 6 coils, one there, and one here. So it's a bit odd, but I've got these 3 fans set up for this circuit, and then I've got these 3 fans set up for this circuit, and there'll be a little bit of bypass through here, potentially a lot of bypass when it's running on just one circuit, but I might put some flaps down, so if they're both running they'll open up, and as this one here is running, that would open up and that would stay closed, which would mean that the air would come through the coil, and if they're both running the flaps would both get pushed up. So that's a solution that I might implement later. So yeah, so we come through here, a discharge gets turned into a liquid, which comes through here. We've got a little liquid line gauge. Now I know this is for R12, but 134A pressures are real similar, so we can see that at 35 degrees our fans turn on, and it's trying to maintain that 35 degrees. I might adjust that later to try and get better performance, but yeah, at the moment this is good. So we come through the filter dryer, come through our little connections here. So I've got the fan speed controller, which is off a Temperzone R22 heat pump. So it's a head pressure controller. So this takes the pressure of my liquid line, has a little bellow in there with I think a potentiometer, which then sends a voltage to this guy here, and then that basically controls, that's the voltage from the unit down the back there, and then my fans are connected on the bottom here, and then they're controlled here. Now these don't like being turned on and off, but it's as good as I can get, and sometimes I can see some little electrical sparks in there, but it's all good. I'm sure I can replace them when the time comes. So after the fan speed controller, we drop down to just my service port. We've got ball valve there, and we've got a ball valve on the other side of that dryer just up there, and that means that I can pull that dryer and replace it, and then obviously with the service port on the inside of that ball valve means I can just pull a vacuum on that if I ever need to. I've got my testo gauges hooked up at the moment, so we can see we're evaporating at 2 degrees. We've got superheat of 8.2 degrees, which is, 2 degrees, 8 degree pipe temperature, superheat of 6K, which is perfect, I guess, for a fridge world, but I wouldn't mind getting it a little bit lower. Unfortunately I probably can't, because I've actually wound these valves open to 100%, so I'm not sure, maybe that's just a design fault, but 6K is pretty good. And then this is our high side, so we're condensing at 35, sorry, and our liquid temperature is 29, so we've got a bit of subcooling there. Looks like we're stacking up a bit of liquid, but again, that's all good. And you can see that changing with the head pressure controller running. So come back down here, we've got our liquid line coming up to our expansion valve, and this, it didn't have to be externally equalized, but that's all I could find. This project's basically built out of 3 parts, so that's the external equalizer hooking into the suction there, off the top of the barrel, and yeah, and then in this insulation obviously I've got the bulbs for that, so the sensing files, or sensing bulbs, whatever you like to call them, come in here, and then we're dropping in pressure into our flooded evaporator. So I got this tube welded up with some end plates, so it's just 150mm tube with a, I think, inch spigot put in there, and then some 1/2-inch spigots on the bottom, and then some plates on the end, and then I've drilled holes and I've put a whole bunch of copper lines through there. So the refrigerant in the system comes up through here and boils off inside this tube, and then the water's getting passed through the tubes in here. And so the water comes in this line, gets pumped with that guy there, gets pumped into the heat exchanger all the way down there through all the refrigerant, and then on the end here we're coming through. So this here is sort of just an open box, but if you can imagine, all the tubes point that way, and then the water just kind of comes around and back through there. And that's our intermediate temperature probe, so that's checking the temperature halfway through the coil. And then the water comes out and goes into the buffer tank. So the buffer tank is just an old refrigerant cylinder, just like this one, that I've insulated. I've welded some ports on, and chucked some ports on the other side as well. And then so this is our primary circuit. So just like a commercial building or something, you'd have a primary circuit supplying your buffer tank and chiller with water, and then you've got your secondary circuit, which is your load side. So this would technically be our building, and so currently I'm just cooling my garage, and if I want to add load, I can turn on that heater there. Yeah, so I'll just wait for it to run back up, and then I can show some numbers. It's just cycled off, so I'll be back in 2 seconds. Sweet, so I've just turned this heater back on just to give my system some load, just so I don't have to stand around and wait for ages. So that heater's heating up the, I guess essentially the air handling unit, or just in this case the water coil, which in turn is heating up my buffer tank, which in turn is heating up my evaporator. And so the chiller's detected that it needs to run, and now it's running system 1, because last time it started on system 2, so that's pretty cool. And then we've got that minute delay for the compressor 2 to kick in. So currently with one compressor running, we've got a delta T of 1.1 degrees, or let's call it 1 degree, and we've just got our second compressor that's kicked in, and there go our fans. So just loading the system up. And if we come round to our gauges, so we can't really look at the high side because the high side is hooked up to system 2, but currently I'm running system 1. So we'll just look at the low side because the low side is shared. And again, yeah, we're looking at that 6K superheat, 5 degree evaporating, and 10 degree pipe temperature. So as you can see, I need to sort out some insulation because it's getting quite wet. And then here's the system now running with 2 compressors. So you can see the delta T is about 2K now. So it's about 1 degree per compressor. So all 4 compressors running, we get about 4 degrees change in temperature, and with one we get 1. Yeah. So that's my little system that I've built. It's a lot of rambling. The video's a lot longer than I thought. If this gets any interest, I might do some other videos of it. And if we have any ideas of what I could cool with it, let me know. I just built it for fun. So yeah, perhaps see you on the next one.